Welcome back, everybody, to the second half of our afternoon session. We're going to get right into it here with a presentation from OrbitsEdge.
Hello, and welcome to OrbitsEdge. I am Sylvia France, the president. We are building a specialized satellite that will be able to place edge computing and storage in orbit, providing thousands of times more processing and storage than ever done before. But before we go into the details, let's frame the problem and why this kind of solution is needed in space. Let's say you want to watch a show on Netflix. If your bandwidth is not fast enough or unavailable because weather impacts your dish, you can't watch your shows. Imagine how upset you'd get. That's what's going on today with commercial satellites. The good news is service providers have continuously upgraded home data services. These upgrades include network, storage, and processing, providing us net flips at our fingertips. It has also opened up new opportunities to create content, revolutionizing our TV experience. For commercial satellites today, we have limited communications in orbit, limited processing, and practically no storage. This has to be fixed and is exactly what OrbitsEdge plans to do. Let me introduce to you Bentley Radcliffe, one of our co-founders. He has been a pioneer in the cloud and edge computing industry. Bentley, can you share why we think this approach is right?
Thank you, Sylvia. I like the television analogy and would like to add one additional point. When you click on Netflix, it is not just internet bandwidth. When the logo comes up, a computer is validating your credentials. It has to find your data in storage, then process and provide you a custom menu. When you stream the video, the computers move the video to a server that is close to you, dramatically improving performance. This is what is called edge processing, and exactly what we are going to do in space. Edge computing, also known as MEC, or multi-access edge computing, is one of the fastest growing sectors and delivers high-performance computing and storage and communications right where the data is created. According to McKinsey report, edge computing represents a potential value of $215 billion in hardware by 2025. OrbitsEdge, in association with our partners, is delivering edge computing for space as a service. Ross, can you provide a deeper dive into the technology?
Sure. CPUs used in space must be radiation hardened, and that process takes many years of development, and the result is that each chip uses technology that's at least 5 years out of date and has only the performance of a first-generation iPhone. Also, chips can cost as much as $200,000. A typical Earth-developed edge computer CPU is 20,000 times more powerful. OrbitsEdge is taking a different approach to solving the radiation problem. We're producing a frame that will protect ordinary Earth equipment from the harsh space environment instead of building custom technology. Our goal is to take the custom out of the satellite. We intend to launch an initial constellation of 30 satellites into LEO in 2024, what we call an edge above the clouds, each containing 5,000 of these vastly more powerful industry standard CPUs delivered in a zero-touch, zero-maintenance model. The constellation is designed so that each satellite features a full 42U rack of high-performance computing equipment that consumes up to 15,000 watts. A large solar array and battery pack allows the system to operate at full performance continuously, whether the satellite is in sunshine or in the shadow of the Earth. The equipment inside is actively cooled to optimal operating temperatures, and the heat the systems generate is dissipated into space through large radiators. And thanks to an extremely effective radiation shield, the internal computers will actually experience less radiation than if they were operating on the surface of the Earth. Our shield will dependably stop particles with charges up to 400 megaelectron volts, and this is an important feature for future quantum computing needs. While computers will continue to improve over the next few years, if we just use today's technologies, each satellite would feature 5,000 processors, 70 terabytes of memory, and 12 petabytes of storage. High-performance communications will allow OrbitsEdge constellation to be used as a relay network through the use of phased arrays for radio, together with a dozen laser communication systems for both satellite to satellite and also satellite to ground. And we intend to seamlessly interface orbiting communication networks such as NASA's TDRS, DoD's MILSATCOM, and SpaceX's Starlink. NASA missions currently produce over 2 terabytes of data every single day, yet only a fraction of this total can be transmitted down to Earth, because global downlink bandwidth is a severe bottleneck. Even with new communications networks such as Starlink, the ever-increasing amounts of data produced by NASA, other agencies, and commercial customers will far exceed the capabilities to transmit it all down. But if you could have inexpensive and plentiful computing power and storage that we just described available in space, the option to process the data up there becomes feasible. The most obvious example is to examine images of Earth observation satellites, and those that contain nothing useful, perhaps filled with clouds or empty ocean, can quickly be sifted from the valuable data that needs to be transmitted down to Earth. Security is also massively improved with increased computer performance. With only iPhone 1 levels of performance on the current satellites, the ability to compress and encrypt data is severely limited, and the satellites themselves cannot implement firewalls or other modern security measures, so they're vulnerable to many forms of cyber threat. If the satellites could utilize a network between them and the ground to provide those security capabilities, everyone's assets become far less vulnerable.
Thank you, Ross. Now let me tell you why this matters and the value it provides to our customers. The OrbitsEdge SatFrame constellation will streamline satellite operations and be able to consolidate, analyze, and compress data in orbit, allowing satellite providers the ability to make better use of the spectrum, avoid bandwidth constraints, and send only the relevant data back to Earth. This translates to dramatically lower cost and more timely use of data. It will leverage artificial intelligence at the source, allowing for faster decision-making and response for manufacturers, autonomous mining, new chemical composition, and research. This translates to faster ROI and significant market share gains. In NASA's words, it becomes an enabler for small sats and CubeSats that won't have to deploy extensive communications, processing, and storage by offloading to the OrbitsEdge satellite. This translates to lower cost and better returns on the mission. No longer will the massive amounts of data generated in space need to be transmitted to Earth for processing and storage. Since we are based on standard software, companies will be able to leverage IT expertise immediately without having to retrain their teams, saving time and money. Rick, can you share how we approach the development of the SatFrame and maybe one use case?
We have a phased development approach. First, the TAC frame, which is a sealed, ruggedized, hardened, and air-cooled battery-powered solution. It'll be used on Earth in harsh environments for resource extraction and for DoD applications such as Air Force data payload distribution. It'll leverage hardline, satellite, and/or 5G communications. Currently, we're simulating TAC frame operations with a pair of HPE EL8000s. Second will be the C-frame, a liquid-cooled, waterproof, and submersible solution to be used on oil rigs and DoD applications involving saltwater deployment. Currently, we've been running a server submerged in our special oil solution for almost a year. After Phase 2, we'll have reached 60% of the requirements for space. And finally, we have the SatFrame, which is radiation protected and designed to operate in low Earth orbit and beyond. We're sending 2 pilot SatFrames in 2021-22 to verify full mission operations, and then we'll launch a 30-unit constellation into low Earth orbit. In Phase 1 and 2, our frames will be deployed by mining companies, oil companies, and sea transportation. These environments provide somewhat similar challenges to the Moon or Mars and make for a great proving ground. NASA uses the same approach to test technologies that are going to space. This phased approach allows OrbitsEdge to validate frame attributes before launch, develop customer relationships and requirements, and gain immediate revenue streams.
Partnerships are key to the OrbitsEdge strategy. We have signed an OEM agreement with Hewlett-Packard Enterprise to use their Edgeline EL8000s in our satellites, as well as partnerships with Red Hat Software for our software stack to include Red Hat Linux, Kubernetes containers, and IBM Cloud for connectivity.
Hi Sylvia, as IBM's distinguished engineer and CTO for Space Tech, one of my responsibilities is to relentlessly innovate and push the limits of technology. Edge computing is an important part of IBM's hybrid cloud vision, And I believe the edge computing will extend from cloud data centers to terrestrial edge to the lower Earth orbit, providing faster, actionable insights for the data being produced in space.
We also are a beta tester for IBM Cloud Satellite. I would like to introduce you to Joe Vidal of Hewlett-Packard Enterprise, who is an OEM champion for our partnership.
Thank you, Sylvia. One of my responsibilities as a chief technologist for the North America channel at Hewlett-Packard Enterprise, also known as HPE, is to constantly seek out new and exciting technologies that can be added to our own hardware and software-based solutions. What we found is that OrbitsEdge is a natural extension of HPE's commitment to space. The OrbitsEdge OEM partnership takes our spaceborne supercomputer initiative to a whole nother level after successfully running our HPE systems on the International Space Station for over a year. The HPE EL8000s will provide the performance and the security needed for space and other non-traditional outside the data center initiatives, or in this particular case, bringing high-performance computing and analytics as a service above the cloud, or clouds as the case may be.
Thank you, Joe. We are also in conversations with many other companies, including NVIDIA, Verizon, Bentley. Could you share our team and sales strategy?
We are a combination of aerospace and IT company, which is reflected by a diverse and seasoned team, which includes extensive Fortune 50, startup, and military experience. Sylvia and I have worked together for many years at Apple. I have extensive background in sales and plan to lead the direct sales team for large opportunities and will build a channel organization. A reseller channel will be extremely valuable for both ground-based solution sales as well as remarketing our infrastructure as a service solution above the clouds. In the space market, we have initially targeted organizations that heavily rely on Earth observation for time-sensitive decision-making, and pharmaceutical and healthcare organizations that will leverage microgravity for chemical composition. We have been approached by the Department of Defense, specifically the Navy and Air Force, for sea and ground-based solutions, and oil and gas companies to develop a solution for extreme harsh environments on Earth. Other opportunities include mining, utilities, and shipping transportation. All of these opportunities provide a unique, high-dollar niche market and an excellent proving ground for space.
OrbitsEdge has multiple revenue streams, including sponsorships and partnerships through direct investment by organizations, sales of TACFrame, C-Frame for harsh environments on Earth, subscription fees for access to the SatFrame infrastructure in orbit, and sales of dedicated resources in orbit, which is virtual CPU processing time. Sales of storage in orbit, which is potentially terabytes. As you can see in the chart, our sales of the TACFrame and C-Frame will reach 3 million by 2022 and will help organically fund our development of our space mission. Without SatFrame expenditures, we would break even in 2022. After the launch in 2021 of our first SatFrames, we'll produce 2.3 million in the second year. Once we have our SatFrame constellation of 30 satellites in orbit, we expect revenues based on space processing at the edge to reach 365 million in the fifth year.
As of today, there are no direct competitors placing multi-access edge computing in orbit, although we have seen hybrids that consolidate communications and in some cases analyze data in space. In the future, we expect Amazon and Microsoft will have cloud offerings in space, but it is unlikely they will focus on the edge solutions. Right now, they are focused on ground stations for communications. We believe our first to launch status will give us a huge advantage. Our intellectual property is a combination of patents to be filed and trade secrets for power, cooling, heat dissipation, security, and radiation protection.
OrbitsEdge is a unique platform that solves big, obvious problems on Earth and in space. We are attacking a very large total addressable market, which is already huge and growing, have a unique approach to protect state-of-the-art technology from harsh environments, developing proprietary technology currently being validated in our labs on the Space Coast of Florida. We have a compelling value proposition for our customers. We have a strong partnerships with leaders in space, computing, and enterprise software. We have a hybrid revenue model with Earth solutions to validate before space launch. We have experienced and diverse senior level management team, have been recognized as an innovator by NASA, the Navy, and many publications such as TechCrunch and Network World. This is an exciting market opportunity and hope you will want to join us in our quest. Thank you for consideration and the time today.
All right, thank you. Let's go ahead and get to questions. Harry, is that you?
Yep. So I guess one of the questions that's going to come up is your radiation protection for space electronics. Can you say something about how you do it, or say something about how you tested to show that you can protect?
Muted, Sylvia.
You're muted, Sylvia, so I'll just step in.
Okay.
Our radiation protection system is it's a proprietary system, so I don't really want to get into too many details today on the public forum. We can talk about it a little more tomorrow. But it's designed, it's a fairly traditional approach to it. It's a thick, heavy material designed to stop 400 MeV particles. And it actually also produces a little bit of additional cooling capability for us. It's a unique combination of the two.
And so you have tested it in some.
We've done some initial testing with it. We've still got to take it into a vacuum environment and prove that out. And our first satellite launch is due hopefully at the end of 2021. And we're going to take it up into space and prove it out there.
Okay, so one of your premises is that you the data in space. Do you have customers who are willing to do that? Most of the people that I've talked to, the science folks, even though they want all the data back eventually anyway, and I know that slowly switching that people are going to start doing this, but do you have customers ready for that now?
The answer is no. What we've been doing is where we are in our development is we've been focusing on partnerships. So as we mentioned in the video that we have a very strong partnership with Hewlett Packard Enterprise. And we also have been working with others such as IBM and NVIDIA. Red Hat. So what we're doing is we're leveraging their expertise. And actually what's kind of ironic is they are looking at their customers and their customers are actually coming back to us for our solution, especially in the harsh environment sector.
All right, Rich.
There we go. Thanks, Rob. I have so many questions. I don't want to take up the whole afternoon. 15 kilowatt power satellite with cooling, that's a big bird. I presume you're going to be running it at a kind of a medium Earth orbit altitude. That kind of bird, though, is going to cost a lot of money, and you're talking about putting up a small constellation. How are you going to get there? I mean, I know you said you got your first one, you want to put in orbit next year. That's a big hill to climb. Can you provide a little bit more detail on that?
From a tech, Ross, do you want to take that from a technology standpoint? Because our first launches are going to be with our SatFrame 1 and 2, which are a smaller version of our constellation that we're going to eventually send up. So we know that we're going to have to scale eventually, but we also know that we're going to start small with 2 satellites for both Sat1 and Sat2, and then grow in the further constellations once we have the additional learnings.
Over my shoulder, you can actually see one of the EL8000s that we've got as a development unit. This one isn't going to fly, but we're going to fly 2 of these on our first 2 missions on each of our satellites, and we're going to fly a pair of satellites on each mission so that they can test out the communication capability satellite to satellite. These are going to end up being around about 100 kilos apiece for our first satellite, and they're only going to use about 1,000 watts. So these will prototype our systems in 2021, a repeat mission in 2022, which we will use with whatever we learn from the first mission. And then we will scale up to the full-size missions. And those are big birds, as you say. We're hoping to get between 5 and 10 on a Falcon 9, or perhaps even a Falcon Heavy. We may require the larger vehicle.
Okay. And one other question: Do you have you moved forward with your spectrum allocation? Do you have your licenses from IT or FCC?
We've begun the process, but it's going to take a long time. As we understand it, it's going to take about 18 months to be able to get our full allocations. We should have our S and X allocations ready for the first launch, and the others will come online, but obviously we won't be able to utilize the systems until we have permission to do so. It is possible we may be able to piggyback off somebody else's communications capabilities, like, for example, we may be able to test with TDRS ahead of formally getting our own allocations.
All right, John, you had a question?
Yeah, hey, all, John Carr here. So you started to hint at the end with your S and X antenna arrays, the power you plan and the schemes you plan on using. At what ranges do you think this is going to be useful for edge computing? How far away can my satellite be and still gain the benefits that you're offering?
Shall I dive in again?
Yes, please.
We're initially planning to put these into a 600 kilometer approximately orbit around LEO for the first 30 satellites. But we actually have a plan that we are in the process of putting together an unsolicited proposal to NASA to send 5 of these to lunar orbit in support of the Artemis program. So having 15,000 processors and many petabytes of storage in local communication to assets on the lunar surface could be very useful.
All right, Peter?
So I'm still trying to understand what your business model is going to be terrestrially or here on Earth. Who are the target customers? How are you going to, and second thing is kind of what Richard was getting at, how are you going to capitalize this huge expense of this network? So those two are just such big problems.
Bentley, why don't you talk about that?
Well, I mean, there's a vast number of customers that we've started to talk to. And just the other day, I was on the phone with companies like Halliburton and of course I've been doing a lot of work in the oil and gas world, so I've also been speaking with them. And as Sylvia mentioned, IBM and us have been defining a series of their top 75 customers that they want to approach for this solution. As far as capitalization is concerned, from an obvious launch place, obviously we need a VC capitalization, but as far as our revenue plan is a combination of licensing fees, raw processing, very big market for storage in space where there isn't anything right now to fill that gap, as well as backhaul, but obviously taking the raw data and boiling it down into some level of intelligence before it's transmitted back to a local cloud. We're not trying to be the cloud in space. We're trying to be a consolidator, an edge solution that collects data, that can process it, and then send it down for the final processing in the cloud marketplace. Very much like what's happening right now. And the reason I used Halliburton as an example is just on Monday, I was on the phone with them when we were talking about the edge solutions that they're placing out at their remote wells. Actually, Phillips 66 was on the line with me. And it was a great conversation because we're talking about the problems with communications at remote locations. Is very, very difficult to drop any kind of fiber or anything in the line. That the fact that, and I saw that Sunil called out in one of the other pitches of sawing the windmill tearing up, these kinds of things happen all the time. And what they were saying is by placing the system at the edge, yes, they improved their ability to either shut down or evaluate situations ahead of time. But what they didn't expect was all the new things that they could do in these remote locations and the lack that they don't have to have as much communications. Today, everything is kind of dependent upon communications. Right, and you need a high bandwidth. Well, when you don't have it, you want to try to put the processing closer. And so the idea is that in our case, we're going to place that processing and that storage right there where it's needed. Okay, and then only transmit down, or maybe not transmit down. Maybe an AI solution actually will respond. We have a full set of financials of how we expect that to go. That actually we did work through with one of our cloud partners. And it's quite detailed. If you want to see it sometime in the future, it's something that we might be open to discussing with you.
Thank you.
There's a lot of opportunity.
All
What's
right.
that?
All right, Paul, and then Cheryl.
Thanks, Sylvia and Bentley. Nice job. Big market demand and need.
Yes.
You earlier described that your first step was to form partnerships.
Yes.
Can you describe to us the categories and types of partners by function that you decided to approach, and therefore what you need from each of those categories to build out your model, your business model?
Yes. So, for example, we specifically went to Hewlett Packard Enterprise for hardware because of their experience they've already had on the ISS with their space-borne computing. And what's really been great about that partnership is that they've actually shared their insights, so that's helped to speed up our development. Then we went to partners like IBM and for our software stack. And then also it was a natural going to talk to people like Red Hat as well. And we were actually approached by Verizon with some of the conversations that they've had with some of their DoD partners about working with Zero Trust. So right now we've been going for partners for specific expertise and specific need has been our strategy so far.
Okay, can I just clarify something? It sounds like, Sylvia, that you've described a hardware partner and a software partner and kind of a system operator partner.
Yes.
Where then is your company's value added, and what form potentially a platform company would it be?
Bentley, do you want to take that?
Yeah, I'm not sure I totally understand the question.
Yeah, that's where, to understand the question. What do you mean by a platform partner?
So let me change it to, so you approach one for hardware, software, systems operations.
Yes.
Therefore, what is the value added? Are you the integrator? Is that really what your company is the value added to come to market, the integrator?
I guess you could say that. There's different requirements. Like, because we're not a massive data center, right? We're not IBM or we're not AWS or one of the big data centers. We can only take so much data at a certain point. There will be different analytics platforms, as an example, different AI platforms that we're going to run on that solution. But our plan is to provide basically the hardware platform with the base level of an open standard, and that's critical because we want companies to be able to actually leverage their IT resource, and then be able to go to a cloud partner to buy that. So in part of our sales strategy is to leverage partners in these areas, and then let the customer choose some of these base solutions. I think that's what you're asking as far as the platform. So yes. we are basically be like it's not like a fair thing, but we're like the colo center with all the SaaS software already loaded, but it's flying around in space.
Got it. Yeah. Right. Thank you.
All right, last question, Cheryl.
So if capital wasn't an issue at all, what else would your constellation of satellites have, from a feature or hardware perspective?
You're talking about processing? I mean, the whole idea
of processing, storage, bandwidth, anything, if it wasn't a cost function, would make a better product in your plan, but right now it's not affordable.
Ross, why don't you take that?
Sure. I think probably the number one thing that we would like is more satellites. We're going to start out with 30, which gives us basic global coverage, but we want to add another 60 within 18 to 24 months. So it's about capacity at the end of the day.
Thank you.
All right. Thank you very much. Max, back to you.
Thank you, OrbitsEdge.